Hello students, for class 12 video on chapter determinant. It is the chapter 4, determinant. Now what is the determinant? Every square matrix is associated with a unique real number which is known as determinant of the matrix A. And the determinant of matrix, so determinant is of what? Determinant is of a matrix, and it is denoted by DET, means determinant A, or within vertical bracket A. Now for determinant we should know the following facts. 1. Only square matrix has determinant. Only square matrix has determinant. Next, this symbol, it is for determinant A. Don't read it as absolute value of A. The numbers A11, A12, A13 as we write, these are the elements of the determinant. A determinant can be expanded along any row or any column. A determinant is used to solve the system of linear equation. We will solve this one, it is in our syllabus. To judge the invertibility of a square matrix, there is whether the inverse of the matrix exists or not. We can judge this one through determinant. The value of a determinant can be represented as a single number. That number may be a real number or a complex number. We can expand a determinant by any arbitrarily chosen row or column. That is, we can expand a determinant along any row, row 1, row 2, row 3, or along any column. There is C1, C2, C3 can be done. Now value of a determinant. Determinant of order 1, 1. That is 1 by 1, a square matrix 1 by 1. So if the matrix is this, then the determinant of that matrix will be the same element. If it is of order 2 by 2, that is, if A is equal to this matrix as I have written, its determinant will be this diagonal. This is the principal diagonal. This diagonal minus this diagonal. Hence, determinant A is equal to A11 into A12 minus A12 into A21. Determinant of order 3 by 3. Now determinant of order 3 by 3. So this is 3 by 3 means 3 rows and 3 columns are there. Now we can expand this one along any row or any column. I am showing you that is how to expand this determinant along R1. So first element A11. But before that, let us choose the sign. Start with plus, minus, plus. Okay? Plus, minus, plus. Now A11. Now leave this row and leave this column. We will have this sub-determinant. So A22, A23, A32, A31. 33. Then minus of A12 into. Now leave this column, leave this row. That is, we have to delete the row and column of which the element belong to, in which the element belong to. So we have minus a12 into a21, a23, a31, a33. Similarly again plus, so a13, then determinant, leave this column, leave this row, a21, a22, a31, a32. Now these are all determinant as we have calculated this one, order 2 by 2. These are determinant of order 2 by 2. So a11, then this diagonal minus this diagonal. Minus of a12, this diagonal minus this diagonal. Then plus a13, then this diagonal minus this diagonal. We will get the value of the determinant. But we must write along which row or column we have expanded the determinant. So expanding along R1. Now minor and cofactors of a determinant. Now minor of a determinant means minor of element of a determinant. It is obtained by deleting the row and the column to which the element belong to. Suppose that minor of this element. So how to get the minor of this element? Leave this row, leave this, delete this column. So we have this subdeterminant. Now this subdeterminant, it is the minor of a11. It is represented by capital M, M for minor, 11, 11 for first row. That is the element belong to first row and first column. Now a22, a23 and a32, a33. If we calculate this one, we will get the numerical value, whether real or complex, whatever may be, but that is the minor of that element. Remember, minor of a element does not have any sign. Now cofactor. Now according to its position, suppose position means that is a11, a12, a13 plus minus plus minus plus plus minus plus minus plus minus plus minus like this. Now how to get the sign? It is the rule. The sign will be the element and its sign will be minus 1 to the power. Now this element suppose belong to ith row and jth column. So I plus j. Then mij, that is the minor. Okay. So if we see that I plus j is odd, then it will be minus. And if I plus j is even, then it will be plus. Now we should know singular and non-singular matrices. Singular matrix. A square matrix is called a singular matrix if its determinant is 0. There is a singular matrix, and if the determinant of the matrix is not 0, then it is called a non-singular matrix. Now value of a determinant using cofactors. Say this is the determinant. Elements are a11, a12, a13 as we represent in general. Now actually whenever we are calculating the determinant along any row or any column, what we are doing that this element into this, what is the sign? Plus, then it is minus, then it is plus. But this is actually what? The cofactor of this element. So a11 into c11 plus a12. Now what is actually this? It is actually the cofactor of this element. That is why the negative sign is given, because for this element minus 1 to the power 1 plus 2, minus 1 to the power 3, and it will be negative. That is why negative sign comes. So a12 into c12, there is element and its cofactor, plus third element into its cofactor, that is a13 into c13. Similarly, if we are going to calculate along this one, so a21 into c21 plus a22 into c22 plus a23 into c23. Suppose we are going to calculate along this one, a31 into c31 plus a32 into c32 plus a33 into c33. Similarly, suppose we are going to calculate along the column, first column, then A11, C11, A21 into C21, A31 into C31. In this way, we will calculate this one along any row or any column. Now, we should remember one thing, there is one property about determinant. If a row or a column of a determinant consists of all zeros, that is, if all the elements in a row or in a column are 0, then the value of the determinant will be 0. So we have learnt how to calculate the determinant. Now there is also one rule to calculate the determinant, that is called the Sarus rule, Sarrus or Sarus. Both the spellings are written Sarus rule. Though these are not for the exam purpose, but everything is not the exam purpose. It is not that only for the exam purpose we will learn something, it is not. So we must know. Now let A is equal to the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. The value of the determinant can be calculated by using Sarrus rule as explained. First, we will write this along row A11, A12, A13, A21, A22, A23, A31, A32, A33. Then two more. There is A11, A12, A21, A22, A31, A32. Okay. First of all, what we will do? First this A11 into A22 into A33 plus A12 into A23 into A31 plus A13 into A21 into A32. This ends. No more elements we can take because only for these three elements there are 3. Now this group minus another, this direction, A31, A22, A13 plus A32, A23, A11 plus A33 into A21 into A12. If we calculate this one, we will get the value of the determinant. This is by Sarrus rule. Now some important observations regarding determinant. What is that? If each element of a particular row or column of a determinant is 0, then the value of the determinant is 0, as we have told you. Second, if each element above or below of the principal diagonal, this is actually the principal diagonal. Okay, if each element above or below the principal diagonal is 0, then the value of the determinant is equal to the product. So students, what we come to know, that is, if each element above or below of the principal diagonal of a determinant is 0, then the value of the determinant is equal to the product of its diagonals. So in this case, as you know that this is the principal diagonal and you see that above this principal diagonal all these elements are 0, then the value of the determinant will be, there is a product of the elements in the diagonal, 7 into 5 into 2, that is 70. Next, the value of a determinant, of a skew symmetric matrix of odd order is always 0. Now, this is what kind of determinant? It is the determinant of a skew symmetric matrix, because this is A, this is minus A, this is B, this is minus B, this is C, this is minus C. As because this is A12, this is minus A. This is minus A 2 1. This is A13. This is minus A31. This is A23. This is A32 minus. Then this kind of matrix is called the skew symmetric matrix, and this is the determinant of skew symmetric matrix, and in this case its value will be 0. Next, the sum of the products of the elements of any row or column of a determinant with the cofactors of the corresponding elements of any row is 0. That is, A11 C11 plus A12 C12 plus A13 C13. This is the value of the determinant. Okay, this is the value of the determinant. Now, properties of the determinants. Property 1. If the rows and columns of a determinant are interchanged, the value of the determinant remains unchanged. See, this is the determinant. This is also one notation of determinant, delta, capital delta. This is the determinant. Now what we have done here, delta dash, another determinant. Now see that row becomes columns. There is rows and columns are interchanged, but the value of the determinant remains the same. You will take some example, one example, take one example and do. There is check it at home. Property 2. If two rows or columns of a determinant are interchanged, the value of the determinant is multiplied by minus 1. There is A1 for this determinant, A1 B1 C1 A2 B2 C2 A3 B3 C3. What we have done here, R1 and R2 are interchanged. This is R2. This is R1. R1 and R2 are interchanged. Then the value of this determinant, numerical value will remain the same, but sign will be minus. These are the properties you should know, because maximum cases we have to solve the determinant using the properties. Property 3. If two rows or columns of a determinant are identical, then the value of the determinant is 0. There is A1 B1 C1 A2 B2 C2 A2 B2 C2. What we see? R2 and R3 are identical. So the value of this determinant will be 0. Now property 4. If the elements of a row or column of a determinant are multiplied by a scalar, then the value of the new determinant is equal to same scalar times the value of the original determinant. Suppose this is a determinant, these are the elements. Now another determinant, delta dash, which is obtained by multiplying each element, okay, of any row or column by a constant, say k, and a scalar by k. So it's for C3, k C1, k C2, k C3. Then the value of this determinant will be determinant but k times k into determinant. Suppose we have multiplied by 3. Then 3 times of this. If this has value 5, this will be 5 3 15. Property 5. If each element of any row or column of a determinant is the sum of two numbers, then the determinant is expressible as the sum of two determinants of the same order. A1 plus alpha 1 B1 plus beta 1 C1 plus gamma 1 A2 B2 C2 A3 B3 C3. Then we can write this determinant as the sum of two determinants. First one, A1 B1 C1 A2 B2 C2 A3 B3 C3 plus next one, alpha 1 beta 1 gamma 1 A2 B2 C2 A3 B3 C3, like this. Now property 6. If to each elements of a row or a column of a determinant be added equi-multiples of the corresponding elements of one or more rows or columns, then the value of the determinant is not changed. Suppose we have written A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, I want to change the elements in the first column as multiplying the elements of the second column by P and multiplying the elements of the third column by Q, then add to the elements of the first column. So A1 is A1, A2, A3 elements of the first column is replaced as A1 plus P B1 plus Q C1, A2 plus P B2 plus Q C2, A3 plus P B3 plus Q C3. Then B1 C1 B2 C2 B3 C3 as it is. It will be seen that the value of the determinant remains the same. Now property 7. The determinant of product of square matrices of same order is equal to the product of the determinant of matrices. That is, A is a matrix, B is a matrix, and such that AB product is defined. There is multiplication of AB is defined and we get the matrix AB. Then determinant of AB is equal to determinant of A into determinant of B. Now application of determinant, where we are going to apply determinant. It has so many applications, like applications area of a triangle. The vertices of the triangles are x1, y1, x2, y2, x3, y3. Then the area of the triangle obtained, area of the triangle can be calculated through determinant. There is half into. First row will be x1, y1, 1, x2, y2, 1, x3, y3, 1. If we calculate, we will get this. There is, let us put the value, and that is as accordingly you put any value of x1, y1, x2, y2, x3, y3, then you calculate, you will get this value, that correct. Now let A r x, B r y plus C r is equal to 0, r is equal to 1, 2, 3 be the sides of a triangle, then the area of the triangle is given by, these are the sides of the triangle, A1x, B1y, C1, A2x, B2y. There is a straight line, as we write a straight line, three straight lines, because represents the three sides of the triangle. Then area of the triangle is equal to 1 by 2, C1, C2, C3. Then determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 whole square. Where C1, C2, C3 are elements and capital C1, C2, C3 are cofactors of the elements C1, C2 and C3. The equation of a straight line passing through 2 points x1, y1 and x2, y2 is given by xy1, x1, y1, 1, x2, y2, 1 is equal to 0. We will get the equation of the straight line passing through the 2 points x1, y1 and x2, y2. Now condition for collinearity of 3 points. If 3 points are collinear, then area of the triangle will be 0. So this will be 0. So 0 into half will be 0. So if 3 points, say ABC, x1, y1, x2, y2, x3, y3 be 3 points ABC are collinear if the area of the triangle ABC is equal to 0. There is x1, y1, 1, x2, y2, 1, x3, y3, 1. Ultimately, this becomes 0. The area of a triangle formed by 3 collinear points is 0.